Okay. So now for this video, we are going to discuss how to solve the problem, how to solve the electric circuits using mesh analysis, right? Okay. So for mesh analysis, so before going to start solving the circuit, we should ensure that whether the given sources are voltage sources, right? So sometimes the problem they might have given the circuit with some current sources. If so, we have to convert those current sources into voltage sources. Then you have to proceed. We in the last video we have discussed how to convert the voltage source to current sources and current source to voltage sources. Okay, now so for this problem, the problem it is 40 volt. It is a voltage sources. So the problem itself it is clearly given. It is voltage sources. So for mesh analysis, we don't want to confuse it anything so that we can proceed the problem, right? Okay, now so you see here how many loops are there in the given circuit. So this is one loop. I'm writing. So this is one loop, and you take this as loop number one. It is a closed loop, right? You take this as I1. This is a loop one. The current flowing through the loop, it is assumed to be I1. Similarly, this is another loop. The current flowing through this loop, it is I2. And similarly, the current flowing through the loop, it is I3. So before there is a mesh analysis, the first step is we have to assume the current flowing through all the loop, it is it is in clockwise direction, right? Now, so this is loop one, loop two, loop three. Now, so for no mesh analysis, we have to apply Kirchhoff's voltage law, and we have to write the voltage equation, right? You see, apply Kirchhoff's voltage law in loop one. That means the current in the loop, it is I1. Okay, now we know that the Kirchhoff voltage law, it is sum of the sources which is equal to drop, right? You see here in the first loop, the only source is 40 volt. So we can write this is 40, which is equal to. So this 40 volt, it is going to be a drop in 10 ohm resistor, 2 ohm resistor, and 2 ohm resistor. Okay, so sum of the sources, which is equal to sum of the drop. That means this 40 volt is going to be dropped in 10 ohm resistor, 2 ohm resistor, 2 ohm resistor. So 10 ohm drop, it is, so what is the voltage drop in 10 ohm resistor? That is V. V equal to, by Ohm's law, it is I into R. So I is given, I is I1, R is 10. So I into R, so 10 into I1. So that is the voltage drop across 10 ohm resistor. Similarly, for the loop 1, we have 2 ohm resistor. For 2 ohm resistor, 2 current it is flowing. One current it is from I1 current is from top to bottom, and another current for in the loop 2 it is going from bottom to top. So 2 current it is flowing. So resistor R into I1 minus I2. Then plus for the bottom side, we have another 2 ohm resistor. Again, the current flowing through 2 ohm resistor, it is I1 minus I3, because one current I1 it is coming from the top to bottom, and I3 it is going from bottom to top. So 2 into I1 minus I3. So this is the Kirchhoff's voltage law equation for loop 1. So 40 in 40, which is equal to 10 I1 plus 2 I1 in minus I2 plus 2 I1 minus I3. So by substituting, by multiplying by 2 into the I1 and 2 minus 2 into I2. So by solving this equation, what we will get finally 40, which is equal to 14 I1. See, the basic mathematical step is involved between these two steps. You just verify the steps. 14 I1 minus 2 I2 minus 2 I3. So this is equation number 1. Okay. So this is the equation number 1. So we applied Kirchhoff voltage law for this loop 1, and we got one equation. Similarly, for loop 2, we are going to apply. So apply Kirchhoff's voltage law in loop 2. So in loop 2, you see, look at the circuit diagram. We don't have any sources. So all the elements, it is dropping element, right? So the voltage, there won't be any voltage. So we can write 0 in the left-hand side. 0, which is equal to 2 into I1. So this resistor. 2 into, sorry, I2 plus, again, for this 12 ohm resistor, 2 ohm current, it is from right to left. Then I3 current from left to right. So 12 into I2 minus I3 plus, again, this 2 ohm resistor, 2 into I2 minus I1. So by simplifying this equation, so what you will get, 0, which is equal to minus 2 I1 plus 16 I2 minus 12 I3. So this is equation number 2. So we applied Kirchhoff's current law for loop 2. We got one another equations, right? Then similarly, for the third loop, apply Kirchhoff's voltage law in loop 3. Okay. So in loop 3, this is the loop. In loop 3 also, we don't have any voltage sources. So simply, because sum of the voltage sources which is equal to sum of its drop. So that is analogy of Kirchhoff's voltage law. So 0, which is equal to, now this 2 ohm resistor, the current flowing through this 2 ohm resistor, it is 222. Yes, this 2 ohm resistor, again, it is 2 into I3 plus, for this 2 ohm resistor, 2 current it is flowing, I3 and I1. So 2 into I3 minus I1 plus, for this 12 ohm resistor, again, I2 and I3. 12 into I3 minus I2. So finally, by solving this equation, we'll get 0, which is equal to minus 2 I1 minus 12 I2 plus 16 I3. So this is equation number 3. Okay. Now by solving these 3 equations, I1, equation number 1, 2, and 3, you will get your current I1, I2, I3. So based on that, we can calculate anything asked in the question. Okay. So now you have to apply Cramer's rule to calculate the del 1, del 2, del 3. So by the way, you can calculate I1, I2, I3. Okay. For this problem, what is the general equation? It is, what is that? 14 minus 2 minus 2. Again here, minus 2, 16 minus 12. Again here, minus 2, minus 12, plus 16. Okay. Then I1, I2, I3, which is equal to 40, 0, 0. Right. So this is what your equation. Now from this, we have to calculate what is del 1, what is del 2, what is del 3. So del can be calculated 14 minus 2 minus 2, again minus 2 minus 2, 16 minus 2 minus 12, sorry, minus 12 minus 12, again 16, which is equal to, so use calculator to calculate the determinant of this matrix. So what you will get is 4,480. Okay, 4,480. That is your del 1. Now, similarly, we have to calculate what is del 1. So del 1, we have to calculate what is del 1 and del 2. So del 1, we have to replace the first column. What is that? 40, 0, 0. So this 14 minus 2 minus 2, which is replaced by 40, 0, 0, remaining everything it is same, right? So 40, 40, 0, 0. The second column, it is as it is, minus 2. Okay, actually, there is a mistake. For this del, we use calculator to calculate the del. Your del value, what you will get here, it is 1344. Okay. Now, del 1 minus 40 minus 2, again 16, again minus 12, again minus 2, minus 12, 16. So your del 1 will be 4480. Similarly, do the same procedure to calculate del 2 and del 3. So what you will get here, it is 2240, again 2240. So both value which are same, I2 and I3, so del 2 and del 3. Now from this, I1 can be calculated del 1 by del. I2 can be calculated del 2 by del. Again, I3 can be calculated del 3 by del. So del 1 value, as it is, in the previous step, it is del value 1344. So denominator value, it is same for all, 1344. Again, here also it is 1344. Again, 1344. So del 1, 4480. Again, I2, 2240. Again, here also 2240. So you will get the current value 3.33 amps. Again, here it is 1.66 amps. Again, here it is 1.66 amps. So I1, I2, I3, it is calculated. Okay, with this, the problem, it is not completed. You have to check the question. The question what they have asked, they asked us to calculate for the figure shown here. Find the current flowing through 10 ohm resistor. What is the 10 ohm resistor? This is the 10 ohm resistor, right? So the current flowing through the 10 ohm resistor, it is I1. So the current, you have to write the sentence. The current flowing through 10 ohm resistor, it is I1 through 10 ohm resistor. That is your I1, which is equal to 3.33 amps. That is the result. Sometimes they may ask, what is the current flowing through 12 ohm resistor? You see here, there is another one resistor here. We have around some 6 resistors are there. What is the current flowing through 12 ohm resistor? You see here, I2 current and I3 current. The difference between I2 and I3, that is the current flowing through 12 ohm resistor. So in that case, what is that? I2 and I3. Difference between I2 and I3 is 0. So current flowing through 12 ohm resistor, that is 0 amps. So they may ask any current value. So based on the circuit diagram, you have to write the result. Okay. So this is what the procedure, how to solve the circuit using mesh analysis. I repeat. So before going to start solving the problem, you ensure that whether the circuit has all the sources which are voltage sources. If not so, we have to convert those current sources into voltage source. So voltage transformation rule you have to apply. So for this problem, it is given with voltage sources. So directly we can start solving the problem. You have to apply Kirchhoff voltage law in loop 1, 2, 3. All the three equations have to be solved. Then accordingly, you will get I1, I2, I3. Then the final answers can be current flowing through 10 ohm resistor. That is your I1. So final value, it is 3.33 amps. Okay. Thank you.